Hello everyone, my name is Roy Jafari and I would like to welcome you to another video of the data mining series. In this video we are going to talk about data reduction. Data reduction is one of the pre-processing tasks that you may need to do before getting to use an algorithm, specifically data mining algorithms for your analytics. There are many different types of data reductions that you might be needing to do, and in this video we're going to learn what it is and learn about its different types and the methods that this data pre-processing task may have. Let's look at this slide. Okay, so the outline we have here, we're going to first see the distinction between data reduction and data redundancy, and then talk about what is data reduction. After that, we're going to talk about two objectives of data reduction, what are those objectives that a successful data reduction task is trying to meet, and then also talks about types of data reduction and also the methods that we're going to be introducing in this video, and in the future videos we are going to actually go in more details about them. So what is the difference between data reduction and data redundancy? Data redundancy is when you have extra information presented in more than one column in your data set. Data redundancy is also one of the issues that you may have to deal with as a data pre-processing. But the major distinction between data reduction and data redundancy starts as data redundancy is a characteristic of a data set. You say this data set suffers from data redundancy. But data reduction is not a characteristic, it's an operation. You operate some data reduction on your data set, not for reasons that there are extra data in your data set. There are extra information in your data sets for other reasons that we will get to look at. So just to remember, the biggest distinction is that data redundancy, this is a characteristic of a data set. This is an operation done on a data set. So let's move on to the next slide and see what data reduction is. Data reduction is basically, as the name suggests, reducing the size of a data set for one of the following three reasons. One could be for human comprehensions. If we need to visualize something and we have more than 2, 3, 4, 5D dimensions, our human comprehension is limited. We might have to reduce somehow the data in the data sets so we can show those dimensions. So that's one reason. Another reason is computational cost. If you're using algorithmic way of doing your analysis, the algorithmic way will slow down and the amount of computation you need will grow as the size of the data grows. There might be cases as if you don't reduce your data, the algorithm is not going to run within the amount of time that you need the algorithm to run. As in, the algorithm will take longer than the amount of time you would have needed or you would have been able to use the information that the algorithm gives you. Another reason is curse of dimensionality. And some of the statistical approaches, when there are just a lot of dimensions in your data, start being usable because as the number of dimensions grows and there are so many dimensions, there are so many attributes, the space becomes neutral because just number of attributes is too much. Then there is not much difference between the data objects, and that distinguishability that the statistical approaches can rely on somehow get lost in the number of attributes. So we might have to reduce the number of the attributes, and that's what's called curse of dimensionality. So next we're going to talk about what are the objectives of data reduction. There are two objectives that a successful data reduction should always balance out. So there is one objective that we want to obtain a reduced representation of the data that has a lower volume, lower amount of data. But at the same time, we want to make sure that we are keeping the most important part of the data. We are keeping the integrity of the data. We are not introducing bias. We are not getting rid of very important information and so on and so forth. So we need to find a balance between these two objectives. And each of the methods that we will go over in the future videos will discuss about how we should keep these two objectives in mind. One other thing that we need to know is that we have two types of data reductions. One is called numerosity data reduction, which is basically the act of reducing the number of data objects or rows in your data set. And then another, we have dimensionality data reduction, which is also reducing the number of attributes or columns in your data set. In the next couple of videos, we are going to look at these methods. We are going to look at three methods for numerosity reductions: random sampling, stratified random sampling, and random sampling smarted by clustering. And also for dimensionality reduction, we are going to look at a couple of methods such as regression, decision tree, random forest, functional data reduction, and principal component analysis, and also computational dimension reduction. So as I promised, in the next couple of videos, we are going to get deeper and further details about these methods that we have on this slide. All right, until the next video.